there, geometry students. This is Miss Hefty here. We're doing a review of Algebra 1, and our concept today is simplifying radicals or roots. And so I am going to explain this process in two ways. First, I'm going to review what perfect squares are. 4 is a perfect square because it's 2 times 2. So if I take the square root of 4, I get 2. 9 is a perfect square because it's 3 times 3. The square root of 9 is 3. What's the next perfect square? You're right, 16. Because when you take the square root of 16, you get 4. Square root of 25. 25 is a perfect square because when you take the square root of 25, you get 5. So I'm going to use perfect squares as one example to help me simplify radicals. Before we begin, you may not use calculators that simplify radicals or roots. So I've put the TI-30XS, and you have a picture of it here, and also the Casio. A number of different calculators will simplify roots for you, and I'll be walking around and looking at those during the class time. But you may not use calculators that simplify radicals on your homework or on your quizzes and tests. All right, so let's take a look at our examples here.
Hey staff, we will meet for just a few minutes.
Okay, well there was Dr. J. Let's take a look at example number 1. I'm looking at the square root of 180, and so I'm going to first do that by perfect squares. So when I look at the square root of 180, I think of that as being 9 times 20, because 9 is a perfect square. I'm writing that down. All right, when I look at 20, I think of 4 going into 20, so then now I go 9 times 4 times 5, and the square root of 9 is 3. The square root of 4 is 2, and I cannot do anything with the root of 5, so I write the square root of 5. So then now my final answer is 3 times 2 is 6 root 5. That's one way to solve this problem. Your second way would be to make a factor tree, 180. Again, I'm doing 9 times 20 is 180, 3 times 3, 4 times 5, and then 3 times 3 times 2 times 2 times 5. Then I'm going to write that all underneath the root. 2, I'm doing them in descending order, 2 times 2 times 3 times 3 times 5, and then I'm grouping them in 2s because it's a square root, so that's going to give me 2. Square root 2 times 2 is 4, square root of 4 is 2, 3 times 3 is 9, square root of 3 is 9 is 3, and then root 5. So I have 6 root 5. So there's my answer. There's my answer. 2 different ways to solve this problem. All right, let's take a look at our next example. 120 a squared b raised to the 5th c to the 4th, all under radical. So when I look at, I'm going to do my perfect square way. When I look at 120, I think of 12 times 10. And I got a squared, b 5, c 4. Okay, now when I look at 12, I think of that as 4 times 3. No perfect square goes into 10, so I'm going to leave that alone. And then now I'm going to write them all out. A, B, B. 5 B's, 4 C's. Okay, so now, square root of 4 is 2. I cannot do anything with 3 or the 10, so I'm going to leave that under radical, under the root. I left some room here because now I'm going to do my letters, my variables. I'm circling them in groups of 2 just like I did back here. All right, so that gives me a regular A. I've got a B and a B there. And there's one B left here underneath the root. And then C's, 1, 2, C, C, and no C's underneath the root. Now I need to simplify that numbers first. letters that are not underneath the roots. A, there is a B and a B, so that's B squared. C and C is C squared. And then underneath your radical, you have your numbers first and your letters second. Now, in your book, you're going to see absolute values. We're not going to write absolute values around our variables. So this is our final answer. Okay, let's go on to the next example. All right, I have root 5 times root 10. So if you want, one way you can do it is you can multiply these together and get root 50, break it down into perfect squares, 25 and 2. Square root of 25 is 5, root 2. That's one way. The other way is you can just break them apart. Root 5 and 10 is root 5 times root 2. Same thing, square root of 25 then. Square root of root 2, you get 5, root 2. So two ways to solve that problem. Let's take a look at our next example. We have the square root of 56 over 45. First thing you need to do is break that fraction into 2. Square root of 56, square root of 45. Now go ahead and simplify each one of those radicals. So when I look at 56, I think of 8 times 7, and when I look at 45, I think of 9 times 5. Now, 8 I need to break down. I'm going to write that as 4 times 2 times 7. Now, some people might be saying, Mrs. Hefty, could I have not done this step and went right here? Yeah, sure, that's fine. I'm just writing all the detail down here because somebody might be saying, where did you get 4 times 2 times 7? And then I've got 9 times 5. All right, square root of 4 is 2. Then this is going to be root 14. Square root of 9 is 3, and then I have root 5. Now, keep in mind here, people, you can cancel if, like I had 2 over 4. I cannot cancel the 2 and the 3. This is improper. That is not correct mathematics. You need to move that root to the top. So to get the root to the top, you multiply it by itself. This is 1. Root 5 over root 5 is 1. That's why I'm doing that. All right, so now on the top, I've got 2, and I've got root 14 and root 5. When I multiply root 14 and root 5, I get 70. On the bottom, I still have my 3. Root 5 times root 5 is 25. Square root of 25 is 5. So now I have 2 root 70 over 15. Okay, so let's move on to example number 5 and 6. In example number 5, again, we have fractions underneath our radicals. So let's break them apart. We got root 3, root 4, times root 5 over root 2. I'm going to rewrite this now. Root 3, root 4 is 2, times root 5 over root 2. I'm going to multiply across. I'm going to get root 15, and on the bottom I get 2 root 2. Now I'm back where I was on that last problem where I cannot have a radical on the bottom. That's improper mathematics. So to get rid of the root 2, I'm going to multiply by itself root 2 times root 2. That gets me root 30 on the top, and then 2. And root 2 times root 2 is root 4, which is another 2. So now I have root 30 over 4. Again, you cannot have radicals on the bottom, so you multiply by itself to get rid of it. Let's take a look at example number 6. I have on the bottom, on the denominator, I have 2 plus root 3. Now this is a quantity, so it has parentheses around it. So first I look at root 8, and I can simplify that. Root 8 is 2 times 4. And I have 2 plus root 3 on the bottom. Square root of 4 is 2, root 2. And then I still have 2 plus root 3 on the bottom. That's a quantity, so I put parentheses around it. At this point, I think a lot of you are thinking, okay, get rid of the root 3 on the bottom. That's not proper mathematics. And so here's what you're thinking. You're writing root 3. This is incorrect. You're writing root 3 and root 3. The reason why this is not correct is because then you need to distribute, and that bottom will be 2 root 3, and you won't get rid of that root 3. So that is not correct. Let's go ahead and get rid of this. When we have a quantity, we multiply by what's called the conjugate. 2 minus root 3 and 2 minus root 3. This is called a conjugate. Again, people, you cannot use your calculators on these. You need to do the mathematics behind it. All right, so let's take a look at this. I have 2 root 2 times the quantity 2 minus root 3. Now, remember, you're multiplying a binomial by a binomial, so you're going to use FOIL, first, outer, inner, last. My first, 2 times 2 is 4. Outer, 2 minus 2 root 3. Inners, root 3 and 2 plus root 2 root 3. And then my last is root 3 times root 3, which is root 9, which is a 3. Now notice here, people, I'm getting rid of my radicals. A minus 2 root 3 plus 2 root 3 is 0, and that was what I wanted to happen. I wanted to get rid of those radicals. So at this point now, I'm coming up here, I'm in another row, maybe you are too. On the bottom, I have 4 minus 3. These are gone. On the top, I have 2 root 2 times the quantity 2 minus root 3. Now I need to distribute 2 times 2 is 4 root 2 minus 2, and then root 2 times root 3 is root 6. And that's all over 1. And so I don't need to write it all over 1. So I have 4 root 2 minus 2 root 6 as my final answer. So now you're ready to go ahead and do your review on your radicals, simplifying radicals. You guys have a great night, and I'll see you in class tomorrow.